Hello and welcome to this session. In this session we will see a practical example including both ADC and PWM. You can see here we have a potentiometer connected to A0 and an LED connected to pin number 3. And you can see pin number 3 is a PWM output. You can see there is a tilde mark there. I hope you remember all our sessions where we have seen all these pins which have this tilde at the beginning. They are PWM outputs. So pin number 3 is a PWM output, and the next probe of LED is connected to ground. And why we need this 100 ohm resistor? This is a 100 ohm resistor because to protect LED. So the potentiometer is 10 kilo ohm, and from end to end it measures 10 kilo ohm resistor. So when we connect end to end to 5 volts and ground, you can interchange these probes, doesn't matter. So end to end voltage will be 5 volts, and while changing this knob, the center point which is connected to knob will change this resistance, and you get a different resistance at every turn. So from end to end you get 5 volts, and when you turn the knob at the center point, when you measure with respect to ground, you get 0, 1, 2, 3, 4, 5 and in between values also. So it's a continuous knob like your audio knob in your audio player. So when you move to the extreme right, you will get the full, that is 5 volts, and when you are at center you get 2.5, and when you are at extreme left you get 0. Right? So this way we are actually using this as an analog input. So by rotating the knob we will get different voltages at different rotations. Now coming to the circuit, this is our live feed. So here you can see we have a potentiometer connected, this one, and of course our LED. It's the same connection what we have seen in our Fritzing diagram. Okay, so let's get started. So let me resize this window and bring my Arduino. So in Arduino you can directly guess what we have to do. It's very simple program, yet interesting though, because you will see both ADC and PWM in action. So pin mode, definitely 3, of course output, pin mode A0, it's an analog input, so input. And also I want to know, we want to know how this analog voltage read from analog read function is. So let's view the output voltage in serial monitor. For that, you know what to do. Serial dot begin. Default baud rate bits per second 9600. Coming to loop, so let me put a variable. So what we have to do is we have to collect the samples from our potentiometer. So our potentiometer will give samples to A0. So analog read A0, and we will collect these samples in a variable, say int digital samples. So these are analog read which are converted into digital samples. And okay, so let me add a small comment here, because it's an analog read and we know it's a 10-bit analog read, just to make sure we remember that. So 10-bit ADC up to how many samples? 1024. So let's quickly view what we have here in serial dot println digital samples. So what we will get here will be the analog conversion, from analog conversion to digital conversion in our serial prompt. So let me upload the program. Control U to upload. Oh, I added a colon instead of semicolon. And it's done. So let's get into a serial monitor, and here you can see the outputs 0 0. Okay, so it's good idea to add some delay. So let's say 100 millisecond. Fine. So now I will slowly rotate this potentiometer and you can see the values changed. So now we are at 300, almost 300. That means we are not halfway mark. So let me rotate further. Now it's almost 512, that is halfway mark. That means we are at the center point, and I'm going till last. So what will be the last one? 1023. This is the maximum voltage, right? Because this is the last one, maximum, and the minimum is 0. So in between you get the in between values. So what is the voltage equivalent of 1023 analog voltage input? 5 volts. And okay, you can expect this to be something like, at the middle you will be around 7.5 or sorry 2.5. So at 512 you get 2.5 something, correct? So this is the analog input, and now we have to change the brightness of LED based on this input. So let me close this window, and so let's get into the other part of the programming. Now this is important. See, you have to understand here we have a 10-bit ADC but 8-bit PWM. So 10-bit ADC shows the values up to 1024, and 8-bit PWM will only vary from 0 to 255, because 8-bit is 256, 2 raised to power 8 is 256, 2 raised to power 10 is 1024. So the values which we will direct to analog write. So first of all, we have to convert these values into PWM compatible scale. So how do we do that? So we have our integer digital samples. So this we have to digital samples. We have to divide it by 4 to get in the range of 256. So what is maximum? 1024. So 1024 divided by 4 is 256. So 256 is the scale for PWM. So now whatever 1024 is will become 255, right? 1023 or 24, they are almost same, don't worry about it. So if I say 1024, it will be 256. If I say 1023, it means 255. So let's not get into that confusion. It's same, don't worry. So when we read from 0, it's 1023, and the total numbers are 1024. Anyway, not getting into that. So digital samples divided by 4. So this will bring down the scale to PWM compatible. So let's store this value in some integer. Let's say PWM samples. Okay. And this PWM samples we will feed to analog write. And what is our pin number? 3. And we will put these samples here. So this is the syntax for analog write. It takes the pin number and the PWM output. So okay, so let's get started. Let me upload it. Okay, so let me open the serial monitor. So we are almost at halfway mark, you can say. So this PWM output is from digital input, okay, digital samples. It's not PWM equivalent. So let's do for PWM samples. Control U to upload. So the PWM equivalent is 122. So halfway mark is 127. So this is close enough. So let me turn the knob, and you can see the value goes to, and brightness of LED also increases. So its max brightness is 255. So now we are at 255. So let me do a anti-clockwise turn, and you can see the brightness is reduced, even reduced. Sorry, it's 72. You might have seen 255 in between because this is a loose connection, because I have just used this pin to directly put into this potentiometer instead of soldering it. So that's why you got that reading. So otherwise it's a smooth reading. You can see when it goes 0, that means PWM 0, which means you already know it's a 0 volt. So PWM 255 is maximum, which is 5 volt in our case, and 0 is 0 volts. Same as input, when you read 1023, it's maximum, that is 5 volts. When you read minimum, that is 0, it's a 0 volt. So let me turn the knob again to clockwise, some reading, and likewise. I hope you understood this program. If not, okay, let me keep it here. So let me walk you through again real fast. Setup, 3 setup for pin number 3, A0 and serial begin. And in the loop we have 10-bit ADC and 8-bit PWM. So 10-bit ADC reads the signal from potentiometer. Here is our potentiometer, and we are reading this signal into A0 pin. So A0 pin analog read function returns number of digital equivalent samples for that analog voltage. So those digital input samples are collected here in this integer digital samples, and those samples are of 1024 scale, so that is 10-bit scale. So we have to reduce it to 8-bit scale, that is 256. So how do we get it? So 1024 divided by 4 is 256. So we get PWM samples, so PWM equivalent samples. And these PWM equivalent samples we can directly feed to analog write, which we have gracefully done here. And pin number 3 is the PWM output. You know, there is tilde marked here. Tilde means it is compatible to digital input output as well as PWM. Serial.println is just to see the debug information. You can press the serial monitor to view the serial input output. Delay 100 millisecond is just because to not make the processor busy all the time. That's it. Hope you understood this program. I did a bit more of explanation, but it's okay. You can understand well, I hope. That's all for this video. See you in next.